She is a chemistry major, and she's been mentored by Joe Muller, right here, and Jennifer Collins from the University of South Florida.
Hi everyone, my name is Shelby Ellis, and I'm here to talk today about my directed independent research project in chemistry. I want to start off by saying that funding for this project was provided by National Science Foundation, the Whitaker Center, specifically Carl Sheffield, Florida Gulf Coast University, and Sea Grant, Florida. And none of this would have been possible without my faculty mentor, Dr. Joanne Muller. So thank you so much again for this opportunity. So why should we be putting our efforts towards hurricane research? Well, what we're seeing is that hurricanes are costing the United States annually $9 billion in damages. And with our population growth and with climate change additions, we're seeing that this cost could go from $9 billion to $67 billion a year by 2100. And 85% of these impacts are expected to be within Florida and the Gulf Coast region. So what this image is showing is that Southwest Florida has a return rate period for hurricanes of 7 years. So this is an image that was created for Michael Berry, and this is just to show you guys what would happen in our community if we were, how susceptible we are to storm surges or inundations of rising sea levels right now. So this is actually what would happen if Naples experienced just 6 feet of storm surge or of sea level rise. You can see how much it would impact our local community. So this is a reconstruction that was created by NOAA, and this is a new intensity scale called PDI that was developed in 2013. And so what this intensity scale is doing is that this is a calculation of storm strength that's taken from wind readings of a hurricane. And this is a duration measurement that we set over a selected interval of time of, say, 12 hours of the hurricane's most intense storm wind velocity. So the time here that we're seeing of the only anti-correlation is around the year 1940. Does anyone want to guess why? Any ideas? What was happening in the world in 1940?
Dunkirk.
World War II. There were no measurements taken. So this is our anti-correlation that we're seeing from this graph. So what we're seeing is that there is a positive correlation between this increase in sea surface temperatures and a hurricane's intensity. So we start to see an even better correlation after 1960, an even tighter one, because the hurricane hunters and technological advancements allowed us to be able to create and find an even stronger correlation between this increase in sea surface temperatures and hurricane intensity. And this is what's really scary, and this is what paleotempestology aims to do, what my research is aiming to do, is our instrumental record is only 160 years old. So we only can understand that hurricanes, what we know about hurricanes, is only going back 160 years. But what paleotempestology is aiming to do is we can go back thousands of years. And when we can go back thousands of years and understand how hurricane dynamics have changed over time, this is when we can start to build models that are better predictors of how Earth is going to respond to these climate changes. So what paleotempestology is, and this is what my whole research project was about, was studying past hurricane events, using geological proxies to extend our hurricane record further back in time. So essentially my research is studying very strong storm surge events, which is a huge characteristic of hurricane destruction. When a hurricane makes landfall or it hits, it's a very high energy event. It's bringing with it strong winds, a lot of rain, and it can have a storm surge threat close to coastal regions. And if this storm surge is significant enough, it can breach the tallest point on the beach, the sand dune. It can take the top of that sand dune and wash this highly inorganic shell and composition, white sandy material, into these back barrier lagoons. And it just pushes it. And these are the types of sites that we look at for paleotempestology. So you can just see it pushes. So this was our Sanibel Marsh site. So we poured on Sanibel, and this is a really important part of paleotempestology, is being able to take the beach transect and to understand what is the tallest point on our beach. So we found that the marsh is likely 150 years old, and the marsh is very much composed of dark, organic, rich sediments that are very small in composition. So with our Sanibel Marsh site, when we got into the beach and we found that it was 72 meters from the Gulf of Mexico, and the tallest point is our dune crest. And our dune crest was found to be 1.7 meters or 5.6 feet tall. So our research methods are, we go into these beautiful back barrier lagoons, we take giant aluminum core pipes, attach handles to them, and we use our arms and we core into the ground. And hopefully when we get back to the lab and we split our samples open, we're hoping to see a sort of signature like this, with this dark, organic, rich material that would be found normally deposited in our lagoons, and these really intense overwash layers that you can really differentiate and see what an overwash layer and what a storm characteristic of paleotempestology is. So what we were able to find is we were able to find 2 tempest sites, characterize them, and identify them. So now our historical hunt begins. After lead 210 dating of our sample and sequentially dating these by each centimeter, we were able to find out that Tempest Site 1 is most likely Hurricane Donna from 1960, and Tempest Site 2 was dated to be either 1910, the Cuba hurricane, or 1926, the Great Miami Hurricane. The reason that we're leaning more towards it being the 1910 Cuba hurricane is because this was a direct hit. And if you remember, our dune site was 1.7 meters, and this storm surge height was 3.65 compared to the Great Miami Hurricane that was only 2.44. So this is where I really like historical science. Historical science is very different than experimental science. With what Manny and Sarah are doing, it's very different from us. We're able to take this, we go back in time and look and dig through historical records and newspaper clippings and articles, and we can see which ones made the most significant impact. So for me, I lived in Lakeland, Florida in the year 2004, and that year was 4 really intense hurricanes that came through Florida, and Charlie was one of them. And Charlie was extremely destructive for our part of Florida, but there wasn't a lot of destruction seen around here. So this is a really big question that I had, was why is Charlie not seen in the geologic record? And through this research, I was able to find out the reason why Charlie won't be seen at our site is because its storm surge height was only at 1.8. And our site, it was a 1.7 maximum. It has to be at least at that height to be able to overwash the sand dune. So going back, Tempest Site 1 is Hurricane Donna, and we use these types of models, and this is called the SWOSH model, which stands for Sea, Lake, and Overland Surges from Hurricanes. So what these models aim to do is to help understand what the storm tide and what storm surges are doing and affecting our area and how tall they are. So when Hurricane Donna struck in 1960, the model predicted that it was going to be 13 feet of storm surge, and the historical record indicates that it was 12 feet. So these models have shown before that these hurricanes are happening, they are intense, and we need to be on the lookout. And this is what I was talking about with Hurricane Charlie that struck in 2004. So at this point in 2004, when Charlie started to reach Cuba, 2 days out, this was a huge storm system that was slow moving. But once it reached this point, it completely changed shape, it compacted, and it started this very large fast forward motion. So this was what actually Charlie looked like from the SLOSH model. So you can see that the tallest point of storm surge reported was 6.3 feet. This was what was predicted 2 days out before it hit Cuba. This is a storm that we would see similar to Lake Donna, but the scary part is that it would have been 17 feet of storm surge. So this is something that we really need to concern ourselves with. If this was such a close call for us. If Charlie wouldn't have changed shape, I mean, these were predictions that were made 2 days out. So consider the implications of a Donna-like hurricane today, something that has a significant storm surge, it doesn't change shape. So our population when Hurricane Donna hit was approximately 60,000 people. But if a hurricane hit today, there are 650,000 people just living in Lee County alone. So currently our research is showing that yes, we are getting more intense hurricanes. And when we add up the factors of Southwest Florida's hurricane return rate period of 7 years, with increasing storm intensity, a strong storm surge, even if the perfect factor would be happening at high tide, with our population growth, this could cause extreme catastrophic damage for our area. So our conclusion of research data is showing that only category 3, 4, or 5 is able to leave an overwash signature behind in our back area lagoons that we can see. from Dr. Muller's other research implications and what she's done, she's been able to find and go back into the record 1,000 years, and she observed more overwashed tempest sites from intense hurricanes during time periods when sea surface temperatures were elevated in the main development region off the coast of Africa. And both the instrumental and paleoclimatology record are indicating that these elevated sea surface temperatures are resulting in more intense landfalling hurricanes. So therefore, we are predicting that more intense hurricanes will be happening in the future with this increase in sea surface temperatures. It's only a matter of time before we don't have a close call, and this is something that, especially with us living near a coastal region, that we need to be aware of, and evacuations and those types of factors need to be taken into account. So thank you so much, Dr. Muller, all the professors and staff that let me harass you all the time, and to Mr. Carl Sheffield, thank you so much for this opportunity. So thank you very much. Any questions? Yeah.
Thank you. I was just wondering, you mentioned earlier about a hurricane or a couple of hurricanes from early 1900s, and I was just wondering, how deep did you have to go for your core before you got that?
Well, it actually was found at around 38 centimeters.
Okay.
So our core was maybe, I think it was 55 centimeters in length, so it was about this long. And just coring and just taking data of 45 points, we were able to go back into 1850, and from that point, we could understand that our marsh site was only 150 years old because the deposition changes and the sediment looks different than the normal lagoon environment. Any other questions? Yeah.
I have a question about the structure of the sediment on surface and bulk. So have you seen any, let me put it this way. Have you tried to measure the composition of your sediment chemically to know how many chemicals do you have, how much? And is there any difference between the surface and the bulk structure?
I have not done that yet. So no, I'm not sure. Maybe Dr. Muller.
You did do calcium carbonate.
I tried calcium carbonate and it failed miserably for me. So I just did not include that.
Would you like to do that for us?
Yeah, you could do that for us. That would be great. More data.
All right, well, thanks, Mary.
Thank you.